Here's how to learn an AI algorithm. My name is Nicole and I'm an AI engineer, and I'm going to be sharing an end-to-end process on how to learn a new algorithm. I want you to fight the urge to go straight into the coding and take a step back. The first thing you want to do is read the documentation. You want to be able to answer what type of problem that algorithm is trying to solve. Is it an optimization algorithm, a search, or a prediction? Every algorithm has a pattern. You'll learn what the parameters are, the assumptions, the limitations, and when to use it. This next step is important. You need to be able to explain that algorithm in layman's terms. And if you're not able to do that, go back to the documentation and just continue that process until you're able to explain the logic and the underlying patterns of that algorithm. You can now move on to pseudocode. Think of this like building a recipe without actually making the cake. If you are a beginner, writing pseudocode is so important because it allows you to go through the algorithm step by step without worrying about things like syntax or specific mechanics of the algorithm. And this is where a lot of the questions come up, and you can use YouTube, Geeks for Geeks, Stack Overflow, and any other resources to break down your pseudocode further. Now it's time to study different implementations. The cool thing about algorithms is that it can be implemented in many ways depending on the use case or the programming language. What you want to do is map your pseudocode to different solutions and understand why it works, why it might be failing. Depending on the implementation, it may look similar or different to your pseudocode, but the key thing here is to map process to process. In my opinion, this is the hardest step because it forces you to think outside of your problem-solving style. I typically do this step on paper because for some reason that mind-to-hand connection eats every single time. This next step, I feel like the computer science folks are going to hate me for it, but it's low-key needed, and that is tracing and debugging. Essentially, what you want to do is take like a toy example, and you want to be able to essentially trace it through the algorithm and be able to understand the outputs at each stage. If you can do that, you're up. Bonus if you can draw it out. Now it's time to code. If you skipped any of the steps that I mentioned before, this is a trial and error phase, and you will definitely go back to those steps as you encounter different challenges with the implementation. As you're writing the code, you're getting errors, you're tracing, you're reading the documentation. It's a rinse and repeat cycle until you figure it out. Now, once you figure it out, you want to contextualize it. This is an algorithm and this is a program. Algorithms are not standalone. Learn how to identify when an algorithm should be used, when it's unuseful, and what the trade-offs are. You want to learn how it fits in a pipeline, how it solves a bigger problem. Identify that this particular problem would be best solved using breadth first search or depth first search. You can stop there, but if you want it to be a full end-to-end process, teach it to someone else. Teaching it to someone else is also teaching it to yourself. It'll identify any gaps in your understanding and reinforce the things that you already know. If you want me to walk through an example with you guys, comment down below which algorithm I should use and we'll do it together. Don't forget to save.